Coding Mama. Today I wanted to discuss an introduction to object-oriented programming in Python. Really, if you have familiarity with Python, it will become second nature as Python is an object-oriented programming language. Objects and methods and classes, oh my. Object-oriented programming can sound confusing, but it's really a piece of cake. And that's actually how we're going to explain it, is by using a cake baking metaphor. So of course these will be digital cakes instead of real cakes. So we have a digital cake baker, and these cakes will have particular characteristics, and we can do certain things to these cakes, like frost them. The first thing we have to introduce is really a class. And class is a code that defines the state of an object and the things an object will be able to do. In this example, our class is cakes. A chocolate cake and a vanilla cake are two distinct objects, but they have two different states, the state of one cake being vanilla and the state of the other cake being chocolate. So for this class cakes example, we're going to try to keep it as close to a physical cake as possible, just to help the listener understand the parallels between the physical world and the digital world. Initial decisions that we need to make when we bake a cake are the flavor of the cake batter, the shape of our cake so we can choose an appropriate pan, and what filling we would like to have when we assemble our cake. Later decisions that we make are what frosting we would like to use to top our cake, if any, and cake shape. You'll notice that cake shape is in both of these categories, initial and later, because fancy cake bakers can reshape their cakes by trimming them after they've been baked. They don't just limit themselves to the shapes of pans that they can find. So again, we're going to be defining a class. That class will be cakes, and it will be all of those objects that come from that class will be different states of cake. The first thing we're going to do is to establish that class cakes. Notice that the first letter of cake is capitalized. So to define a class, we use the syntax shown here. We have class, all lowercase, and then the name of the class we are creating. And syntax, good Python programming dictates that the first letter will be capitalized. So capital C, AKE, open close paren, and a colon. Now, if you have experience with Python, you know what a function is and how it is structured. And this next line of code looks a lot like a function. We have def, the name of the function, open and close paren, and a colon. A method is a function inside of a class. So instead of being a function, this is actually a method. And you'll notice that there is a parameter. The first parameter is self. This will be true of any and all methods that are part of a class. They all need to contain the self parameter. We can add additional parameters, and this is in the example we have about cake. We can go on and define what our batter will be. And I've added a default vanilla, so if I don't specify, I'm going to be baking a vanilla cake. The shape will be round. It will be baked in a round-shaped pan, and I'm not going to have any filling in this cake. This will be the generic cake, the default cake that I bake digitally if I don't add any more information. Now, I need to establish what are the possible states of my cakes. To do that, I will add different self attributes under this initialization function. And that's what __init__ stands for. This first method initializes our cake. It is essential for creating the object that is cake. So, as I said before, some characteristics of our cake need to be initially inputted, the batter flavor and the shape, so we can use the correct pan, and any fillings we need to add when assembling our cake prior to frosting it. Some characteristics are not initially inputted. Frosting, for example, we can decide while the cake is cooling what kind of frosting we want to use. So even though we outline what the possible frostings are when we initialize, we don't have any value. We don't define that characteristic or that state up front. And we can't decide up front. What the default method is none, which would be the 0th index in this list of possible frostings. So since we don't actually specify up here what our frosting will be, how do we frost our digital cake? We do that by adding an additional method. So this method will be called frost. This method will change the state of the cake by adjusting the index that reflects the state of the cake. Our cakes are initially unfrosted, as reflected in this line here, where the self.frostinglist.index none is the self.frosting index. So this is the state of the cake, and that is none, no frosting. We have set a new frosting index, or we can set, a new frosting index using this frost method. And we just need to pick from this list of frostings, which does not seem very exciting as it's limited compared to real life, what flavor of frosting we want to add to the cake. We can also change a previously defined characteristic of our object. For example, if I wanted to trim my cake, we can write methods that change the state of initially defined characteristics. The shape of our cake can be changed by trimming it after it is baked. In real life, we would actually have a limited number of possible transitions between states available, but these digital cakes aren't limited in the way real cakes are. So what I mean by that is, in real life, it would be very difficult to transform a cupcake into a bundt cake, but real cakes sure taste better, despite the physical limitations we have in decorating them. This is the entirety of the code. If you would like to screenshot it or read it carefully, I wanted to present this in the keynote presentation because it is easier to see than in Spyder. I added a little bit of code here at the bottom just so we can look at the state of the cake, visualize the state of the cake easily. So let's go to Spyder and see what this looks like in real life. Let me adjust the size of my window so that it is clear to the viewer. So over here is my code that I just showed you. And over here is where we will be working. I was playing before. So if I wanted to create a cake, let's call it wedding cake, I would say it is equal to cake, the cake class. Now, if you notice, because I have run this before, I have my cake and then I have the default option showing here in Spyder. And so I can do that. And then I can do wedding cake dot show. So these are the characteristics of the wedding cake. It is a fillingless vanilla cake that is round without frosting. Now, what if I was super cool and thought for my wedding cake, I want to do cupcakes instead? I can use that function, the trim function, wedding cake dot trim, and I can define a new shape. So if I wanted to do cupcakes, I can do that. So now if I do wedding cake dot show again, we'll see that the shape has been changed to a cupcake. Now, frosting is my favorite part of a cake, so I can go on and change the state of my cake from being unfrosted to frosted by using the frost method. So I just say wedding cake dot frost, and then my choice of frosting for my vanilla cupcakes, let's do chocolate. Let's show that, and we see that the frosting has been changed to chocolate frosting. Something, I didn't think about was that wedding cakes are typically white. I'm not saying that they have to be. You can be a trendsetter, but since I already feel adventurous enough having a cupcake for my wedding cake, I'm actually going to change the frosting again, and I'm going to make it that buttercream. And so physically what this would be akin to is me scraping off that chocolate frosting and piping some buttercream on. So now I have a wedding cake that I've made, but what if I wanted to make, let's say a party cake of some type? Well, I'll just call it cake 1. Let's say I open a bakery for digital cakes. Let's create another cake, but instead of a vanilla cake, I want to say the batter is going to be equal to chocolate, because that's what my digital customer wants. And they want a chocolate bundt cake, let's say. So shape is equal to bundt. And filling, I want it with fruit. Sounds yummy. Now cake 1 dot show. It's a chocolate bundt cake filled with fruit. Excellent. Now do I want some chocolate frosting on that? You know what? I think I do, because you only live once. Frost. Chocolate. Now I'm going to have cake 1 dot show again, and so I have added chocolate frosting to my digital cake. Now I have completely forgotten about my wedding cake in this process, so if I go back to wedding cake dot show, I find that nothing has changed on my wedding cake, and that's thanks to that self function keeping all of my manipulation and changes of state confined to the single instance or object that I specify. And if I have wedding cake dot method I want to use, wedding cake is self, so all the manipulations are confined to the wedding cake. If I have cake 1 becomes the self whenever I have dot whatever method I want to use. So that self function, that self parameter keeps the manipulations isolated.